Hi everyone, welcome back to this video series on Windows Server 2012 DNS Aging and Scavenging. When using dynamic updates, computers or DHCP will register a resource record with DNS. These records get removed when a computer is shut down properly. A major problem in the industry is that laptops are frequently removed from the network without proper shutdown. Therefore, their resource records continue to live in the DNS database. Windows Server 2012 R2 DNS supports two features called DNS Aging and DNS Scavenging. These features are used to clean up and remove stale resource records of the primary DNS zone. DNS Aging and DNS Scavenging flags old resource records that have not been updated in a certain amount of time determined by the scavenging interval. These stale records will be scavenged at the next cleanup interval. DNS uses timestamps on the resource records to determine how long they have been listed in the DNS database. DNS allows an administrator to set up and configure aging and scavenging through the use of the DNS Snap-In. DNS Aging and Scavenging allows an administrator to perform some of the following related tasks for your DNS servers and any of the Active Directory integrated zones that they load. Administrators can enable or disable the use of scavenging at a DNS server or for selected zones at the DNS server. You can modify the no refresh interval either as a server default or by specifying an overriding value at selected zones. Administrators can specify when periodic scavenging occurs automatically at the DNS server for any of its eligible zones and how often these operations are repeated. Manually initiate a single scavenging operation for all eligible zones at the DNS server, enabling scavenging of stale records. When you install Windows Server 2012 R2 DNS Aging and Scavenging features on all DNS servers and any of their zones, administrators should consider the following settings before using these features. Determine whether you should use aging and scavenging for server-wide settings. When using these settings, you are choosing to affect every one of the zone level properties for all Active Directory integrated zones that are loaded at the server. Determine whether you should use aging and scavenging for zone settings. When using these settings, you are choosing to use them for zone-specific properties for just the selected zones and not the entire server. These settings apply online to the applicable zone and its resource records, and they do not apply to any other zone on the DNS server. Unless these zone properties are otherwise configured, they inherit their defaults from comparable settings that are maintained in server aging and scavenging properties. Monitoring and troubleshooting DNS. Now that you have set up and configured your DNS name server and created some resource records, you will want to confirm that it is resolving and replying to client DNS requests. A couple of tools allow you to do some basic monitoring and managing. Once you are able to monitor DNS, you will want to start troubleshooting. The simplest test is to use the ping command to make sure that the server is alive. A more thorough test would be to use Nslookup to verify that you can actually resolve addresses for items on your DNS server. In the following sections, you will look at some of these monitoring and management tools and how to troubleshoot DNS. Monitoring DNS with the DNS Snap-In. You can use the DNS Snap-In to do some basic server testing and monitoring. More important, you use the Snap-In to monitor and set logging options. On the Event Logging tab of the Server's Property dialog box, see Figure 2.14, you can pick which events you want logged. The more events you select, the more logging information you'll get. This is useful when you're trying to track what's happening with your servers, but it can result in a very large log file if you're not careful. The Monitoring tab, see Figure 2.15, gives you some testing tools. When the checkbox labeled a simple query against this DNS server is checked, a test is performed that asks for a single record from the local DNS server. It's useful for verifying that the service is running and listening to queries, but not much else. When the checkbox labeled a recursive query or other DNS servers is checked, the test is more sophisticated. Our recursive query checks whether forwarding is working okay. The Test Now button and the Perform automatic testing at the following interval checkbox allow you to run these tests now or later as you require. Another tab that's in the server's properties that allows you to monitor the activity of the DNS server is the Debugging Logging tab. The Debugging Logging tab allows you to monitor all outbound and inbound DNS traffic, packet content, packet type, and which transport type protocol, TCP or UDP, that you want to monitor on the DNS server. Simple DNS testing. 1. Open the DNS management snap-in by selecting Server Manager. Once in Server Manager, click DNS on the left side. In the server's window center screen, right-click your server name and choose DNS Manager. 2. Right-click the DNS server name on the top left and select Properties. 3. Switch to the Debug Logging tab. Check all of the debug logging options except filter packets by IP address and enter a full path and file name in the file path and name field. Click the Apply button. 4. Switch to the Monitoring tab and check both a simple query against this DNS server and a recursive query to other DNS servers. 5. Click the Test Now button several times and then click OK. 6. Press the Windows key on the keyboard and then choose Computer. Navigate to the folder that you specified in step 3 and use WordPad or Notepad to view contents of the log file. Troubleshooting DNS. When troubleshooting DNS problems, ask yourself the following basic questions. What application is failing? What works? What doesn't work? Is the problem basic IP connectivity or is it name resolution? If the problem is name resolution, does the failing application use net bias names, DNS names, or host names? How are the things that do and don't work related? Have the things that don't work ever worked on this computer or network? If so, what has changed since they last worked? Windows Server 2012 R2 provides several useful tools discussed in the following sections, which can help you answer these questions. Nslookup is used to perform DNS queries and to examine the contents of zone files on local and remote servers. DNSLint is a command line utility used for troubleshooting many common DNS issues. Ipconfig allows you to perform the following tasks: view DNS client settings, display and flush the resolver cache, force a dynamic update client to register its DNS records. The DNS log file the DNS log file monitors certain DNS server events and logs them for your education using Nslookup. Nslookup is a standard command line tool provided in most recent DNS server implementations, including Windows Server 2012 R2. Windows Server 2012 R2 gives you the ability to launch Nslookup from the DNS Snap-In. Nslookup offers you the ability to perform query testing of DNS servers and to obtain detailed responses at the command prompt. This information can be useful for diagnosing and solving name resolution problems, for verifying that resource records are added or updated correctly in a zone, and for debugging other server-related problems. You can do a number of useful things with Nslookup. Use it in non-interactive mode to look up a single piece of data, enter interactive mode, and use the debug feature. Perform the following from within interactive mode. Set options for your query, look up a name, look up records in a zone, perform zone transfers, exit Nslookup. Using Nslookup on the command line. To use Nslookup in plain old command line mode, enter the following in the command prompt window: Nslookup, DNS name or IP address server, IP address, server IP address. This command will look up a DNS name or address using a server at the IP address you specify. Using Nslookup in interactive mode. Nslookup is a lot more useful in interactive mode because you can enter several commands in sequence. Entering Nslookup by itself without specifying a query or server puts it in interactive mode, where it'll stay until you type exit and press enter. Before that point, you can look up lots of useful stuff. The following are some of the tasks you can perform with Nslookup in interactive mode. Settings options with the set command. While in interactive mode, you can use the set command to configure how the resolver will carry out queries. Table 2.5 shows a few of the options available with set. Look up a name. While in interactive mode, you can look up the name just by typing it, stellacom.com. In this example, Stellacom is the owner name for the record for which you are searching, and .com is the server you want to query. You can use the star there wildcard character in your query. For example, if you want to look for all resource records that have K as the first letter, just type K and star as your query. Looking up a record type. If you want to query a particular type of record, for instance, an MX record, use the set type command. The command set type equals MX tells Nslookup you're interested only in seeing MX records that meet your search criteria. Listing the contents of a domain. To get a list of the contents of an entire domain, use the 1s command. I think that's one, or is, whatever, or ls command. To find all of the hosts in your domain, you'd type set type equals a and then type ls -t yourdomain.com. Troubleshooting zone transfers. You can simulate zone transfers by using the ls command with the -d switch. This can help you determine whether your server you are querying allows zone transfers to your computer. To do this, type ls -d domain name Nslookup response. NS responses and error messages. A successful Nslookup response looks like this: server name of the DNS server, address, IP address of the DNS server, response data. Nslookup might also return an error message. Some common messages are listed in table 2.6. So I'll just leave that off for a minute if anyone wants to read it. Okay, using DNSLint, Microsoft Windows Server 2012 or 2 DNS can use the DNSLint command line utility to help diagnose some common DNS name resolution issues to help diagnose potential problems of incorrect delegation. You need to download DNSLint from the Microsoft Download Center. DNSLint uses three main functions to verify DNS records to generate a report in HTML. DNSLint/D. This function helps diagnose the reasons for lame delegation and other related DNS problems. DNS/QL. This function helps verify a user-defined set of DNS records or multiple DNS servers. DNSLint/AD. Sorry, my nose is itchy. This function helps verify DNS records pertaining to Active Directory replication. So here's just here's the syntax list for DNSLint. I'm not going to read through all this, I don't have time. Okay. Table 2.7 DNSLint command options. You can read through it there if you like. Using Ipconfig, you can use the command line tool Ipconfig to view your DNS client settings, to view and reset cached information used locally for resolving DNS name queries, and to register the resource records for a dynamic update client. If you use the Ipconfig command with no parameters, it will display DNS information for each adapter, including the domain name and DNS servers used for the adapter. Table 2.8 shows some of the command line options available. So I'll just read through these quickly. Command, what does it do? Ipconfig/all displays additional information about DNS, including the FQDN and the DNS suffix search list. Ipconfig/flush DNS flushes and resets the DNS resolver cache. For more information about this option, see section DNS earlier in this chapter. Ipconfig display DNS displays the contents of the DNS resolver cache. For more information, see session configuring DNS earlier in this chapter. Ipconfig register DNS refreshes all DHCP leases and registers any related DNS names. This option is available only with Windows 2000 and newer computers that run the DHCP client service. Using DNSCmd. DNSCmd allows you to display and change the properties of DNS servers, zones, and resource records through the use of command line commands. The DNSCmd utility allows you to modify, create, and delete resource records and/or zones manually, and it allows you to force replication between two DNS servers. Table 2.9 lists some of the DNSCmd commands and their explanations. So I'll just go through these quickly. Table 2.9 command explanation. DNSCmd clear cache clears the DNS server cache. DNSCmd/config resets DNS server or zone configuration. DNS create a directory partition creates a DNS application directory partition. DNSCmd directory deleted directory partition deletes a DNS application directory partition. DNSCmd enumerate records shows the resource records in a zone. Table 2.9 continued. DNSCmd/export settings creates a text file for all server configuration information. DNSCmd/info displays server information. DNSCmd/record adds a resource record to a zone. DNSCmd/record delete deletes our resource record from a zone. DNSCmd/zone add creates a new DNS zone. DNSCmd/zone delete deletes a DNS zone. DNSCmd zone export creates a text file of all resource records in the zone. DNSCmd/zone info displays zone information. DNSCmd/zone refresh forces replication of the master zone to the secondary zone using the DNS log file. You can configure the DNS server to create a log file that records the following information: queries, notification messages from other servers, dynamic updates, content of the question section for DNS query messages, content of the answer section for DNS query messages, number of queries this server sends, number of queries this server has received, number of DNS requests received over a UDP port, number of DNS requests received over a TCP port, number of full packets sent by the server, number of packets written through by the server and back to the zone. The DNS log appears in system root /system32 /DNS/DNS.log. Because the log is in RTF, which is rich text format, you must use Word or Word to view it. Once the log file reaches the maximum size, Windows Server 2012 R2 writes over the beginning of the file. You can change the maximum size of the log. If you increase the size value, data persists for a longer time period, but the log file contains more disk space. If you decrease the value, the log file uses less disk space, but the data persists for a shorter time period. Troubleshooting the .root zone. The DNS root zone is the top level DNS zone in the DNS hierarchy. Windows Server 2012 R2 based DNS servers will build a .root zone with a connection to the internet can't be found. Because of this, the .root zone may prevent access to the internet. The DNS forwarding option and DNS root hints will not be configurable. If you want your DNS to work as a DNS forwarder or you want to use root hints, you must remove the .root zone. Issues with non-Microsoft DNS servers. Although troubleshooting problems that you may run into is working with both Microsoft DNS servers and non-Microsoft DNS servers. One of the most common non-Microsoft DNS servers is the Unix-based Bind DNS server. If you need to complete a zone transfer from Microsoft BND to a Bind DNS server, you need to enable bind secondaries on the Microsoft DNS server. See figure 216. Enabling bind secondaries. If you need to enable bind secondaries, complete the following steps. 1. Open DNS management. 2. Right-click the server name, choose properties. 3. Click the advanced tab. 4. Check the enabled bind secondaries box. And 5. Click OK. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.